If you are not feeling well, you can't concentrate. Okay, we are now working on October, November 2023, 1-3. Right, let's go to number 20,
Wait, Jay, is it 1-3 or 1-2?
1-3.
Yeah.
Okay or not?
Oh no, it's 2024, 1-2 and 2-2.
You want
Oh,
to
yeah,
dis
no, 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 yeah,
we
that's the old
haven't
one.
we
Yeah,
haven't
yeah,
completed it. We haven't
yeah,
completed this
true.
paper yet. We are we stop at 20. Okay, we start at this question. What is your answer?
Yeah,
What is your
1-3.
answer? This one is a bit more challenging. It's related to oscillation, which you study in simple harmonic motion.
So I circle the
Yep,
donkey.
basically it's donkey, correct lah. Right? You have to convert this one to this curve there. Right? Where it's can positive or negative sign curve doesn't matter lah. You have to take the gradient of to find the velocity, you have to take the gradient. So this is 0, and then this part is maximum. This part is 0. So it's a sine curve. Sine curve, when you square it, right, velocity is gradient of displacement time graph. And kinetic energy, you just square this one, it becomes positive, square this one, becomes positive. So within a period, there is that. Lor. So your answer is donkey. Lor. Okay, it's a challenging question, put it this way. Never expect it will come out from 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 A2 lah. Okay or not? Okay, let's carry on 21. Okay, what's your answer for 21?
E,
Say a bit louder.
donkey.
Donkey. Let's display a little bit. Lor. Then you can see which two particles are about to move upwards. Okay. Q is moving upwards. S is also moving upwards. Donkey, correct? Good. How about this one?
A,
Okay, A. About this one?
B,
B, okay?
C, C,
Right? You have to memorize this formula lor, and then apply. Lor. Okay. Angle is from where you start with. Vertical line. Now this is a new, you rotate it through a new axis. So there's the new axis. So. Okay. Okay, C, correct. Which statement containing a stationary wave is correct?
A.
Okay, good. You have to memorize all that lah. Not know how to draw the fundamental, the first harmonic, second harmonic, third harmonic for open pipe, and then know how to derive this formula or memorize this formula. Right? For n wavelength, for n frequency. Then for closed pipe, okay. So these are things you need to remember lah. First harmonic, third harmonic, fifth harmonic, and then fundamental wavelength or fundamental frequency and general formula. Okay,
Boy.
okay, boy, correct. Memory work only this one, nothing much.
Okay, so I put in.
Zero, right? Wavelength, same as aperture, so large diffraction. Okay, number 28.
A.
Go to the formula where D and lambda are constant. So A, okay. So X varies with A as a hyperbola that way. Okay, what's the wavelength of light?
Well, this one I did not.
Okay, you have to divide this by 2 to find, right? The angle is always between straight through, right? This line and that line lah. So that's why I divide this by 2, get 30, then use this formula lor. Lambda is d sine theta, take the n down there, right? And then put in the formula, put in the equation lor. First order, n equals to 1, wavelength, that's your wavelength, and sine 30, answer C, can,
Yeah.
but could not be used to create electric current.
Neutrons.
Neutron, yep. Neutron is not charged. Memory work,
A.
okay, good. 32,
D.
okay. Temperature increases, it vibrate faster, so electron flow can slow down. Okay,
A.
resistance of thermistor decreases as temperature increases. So you can find the PD across 40 ohm is I times your R, that resistance, that's 4.8 volt. Then you can find the voltage across the thermistor, 12 minus voltage across 40 ohm, 7.2. Then you can find your resistance. Okay, good. A.
E.
Right? There's a formula for potentiometer reading or terminal potential difference. Right? E minus IR. Put in your value that's given. Gradient is 0.3, sorry, 0.5. C, okay. Okay, 35.
E.
Okay. The third second law, in a closed loop. C, what's the value of R? The resultant resistance is 8 ohm.
Value or
Yep.
E.
Add these two together, lor. Get one resistor, and then it becomes parallel. The combined resistance, right, or total resistance, 1 over R, 1 over R is R, and this is your 2R, 1 over 2R, and that total resistance is 8 ohm. Donkey, okay. Any comment?
Oh yeah. No.
So Thursday, you want to have it at 5 o'clock lah.
Thursday, yeah, 5 o'clock.
Okay, just one session lah. Okay, what's the answer?
Answer was 37. So I put D.
D, okay. This one,
So I put B.
that one number of electron, lor. B, number of electron equals number of proton. Okay, any comment?
Hmm.
My dog become a Newton. Use me for a while. Okay. Go. Okay, any comment or any question?
So
Oh, let's go to P9 then. What would be your answer?
A.
Okay, 40.
So I think it's D.
Right? Upward charge is 2 third E. Downward memory work minus 1 third E. So upward has a charge of that. Down and strange quad has a minus 1 third E. And try to work it out. 0 can work mentally or can work it out. The answer is donkey. Okay. Any comment?
No.
No. Okay. Okay. Let's go to paper 2-3. Table 1.1. List some physical quantities. Complete the table by placing a tick next to the scalar quantity. So scalar quantity will be charge and power. Okay. Mark yourself. A uniform cylinder has a diameter D, length L, mass M. Density of the cylinder is given. Table shows the data obtained from experiment to determine the density of the cylinder. Calculate the percentage uncertainty in D and L, right? Your answer in table, okay, that one you should be able to do that, right? Calculate out and write it down now. Okay, are you all right?
Yeah, all right.
Calculate the density. Give your answer into three significant figure. Right? That's the formula that's given. Put in your value, substitute, that's all. And then that's the answer. Calculate the percentage uncertainty in density. Percentage uncertainty in density, right? Percentage uncertainty in mass plus 2 times percentage uncertainty in diameter and percentage uncertainty in L. Add them up, 1.8%. Okay,
Mm.
a ball on horizontal ground is kicked towards a vertical wall. Figure 2.1 shows the path of the ball. The ball has an initial velocity u and an angle of 38 degrees to the ground. The ball travels a horizontal distance. That distance is given 9 meters before striking the wall. At a height strike the wall is h. The horizontal component of u h of the initial velocity of the ball is 9.5. Air is seated negligible. Show that the time for the ball to reach the wall is 0.95. So we have given this one. Have been given this one. Calculate the time. Right? Uniform velocity. Okay.
Yeah.
Right? This one summarize for you what is happening. Horizontal component, vertical component, there's angle. Calculate the vertical component of velocity. Right? Many ways to do it. One way is to use tangent, faster. Determine the height h. Right? These are values that are given. Consider the ball being thrown upwards vertically. Right? Take upwards as positive. Write down what is given. This is negative because it's downwards. And choose the right formula to use. We substitute in your value. Okay, can Anything not clear?
Yeah, clear.
The speed of the ball just after striking the wall is less than the speed just before striking the wall. State what indicates about the nature of the collision of the ball with the wall. Yep. Any comment? The type of collision
Inelastic,
inelastic lor.
because loss,
Uh,
because KE is loss.
they just ask you to state only lah. Don't need to give reason, but you give reason, nothing wrong with that lah. Collision is inelastic. State the condition for a system to be in equilibrium. Two conditions. What are they?
Two condition. No resultant force, no resultant torque.
Okay. Resultant force in any direction or no resultant force lah. Resultant moment or torque about any point is zero. Important to okay. Figure 3.1 shows an airship in flight. The airship is propelled by identical fans. These are your fans that can be angled to control the motion of the airship. The upthrust is given at 3,000 Newton. Density of air is 1.2. Calculate the volume of air displaced by the airship. Draw the picture. What are the things given? Then have an idea what's happening. Right? That's the upthrust. And this one is the second part. Thrust. And the weight is pulling it down. So upthrust is given. So that is from your formula sheet. Upthrust is V rho G. Put in your value. Right? And to find volume of air displaced. Put in your value and then calculate. When fully loaded, the weight of the airship is greater than the upthrust. To maintain horizontal flight, the fans provide a total vertical force. Right? That is the one, 3,000 upward thrust on the airship. Calculate the mass of the airship. Forces in equilibrium. Total forces upwards is the total forces downward there. Right? Put in your value, what is given, this two is given, and calculate your mass. Okay, any comment?
No comment.
Okay, so if you can do it, let's carry on. At a certain time, the airship is stationary. In B is stationary. The thrust force exerted by the fan on the airship is 2,800. To produce this force, a mass of 64 kilograms of air is propelled through the blades of the fan in a time of 0.5 seconds. Assuming the air is initially stationary at the entrance to the fan, they try to cover the whole syllabus. for another part of the syllabus. Calculate the change in momentum. Right? Go to the change in momentum formula. Right? Cross multiply. Sorry, that one should be small t. Okay, the speed of the air as it leaves the fan. Okay, 10.
Yeah.
Right? Initially it's stationary lah. So then you have basically final minus initial. Initial is 0. At a certain part 3, the total kinetic energy of this air due to the movement from this fan. Okay, we got 10 more minutes. That is what we have calculated. So write the formula down. Kinetic energy usually is 1 mark there. And calculate out. Put in a value. Okay, 10.
Yeah.
Okay, let's go to number 4 then.
Uh,
Figure 4.1 shows a variation with extension X of the tensile force for two wires R and H made from the same material. The elastic limit has not been exceeded for G and H. On the line in figure 4.1, state what is represented by the gradient. Right? Go to your formula. If you can remember, memorize it. If not, go to your formula. Right? Force equals to Kx. X is the extension, so it's a spring constant. You can write spring constant. If not, write out the formula and then right there's your y, there's your x, so that's your gradient. Explain why the area under the line represent the elastic potential energy of the wire. Yep, can.
wait, why the like, because the work done.
Area represents the work
Uh,
done to extend the wire.
yeah.
Work done to extend the wire is equal to elastic potential energy. That's your 2 point. Okay,
Yeah.
wires G and H are joined end to end to form a composite wire of negligible weight. The composite wire hangs vertically from a fixed support. A block of weight 2 Newton is attached to the end of the wire as shown in figure 4.2. Right, so now they are working on Young's modulus, another topic in your syllabus. Use figure 4.1 to determine the extension of G. Okay, the tension is the same. Right? Both support this force, the tension is this one. So just look at 2 and the extension. Use a ruler to get your extension and extension for H, expansion for G, then read it out. Okay, check you always remember this one normal C either you right or wrong. Okay lah, right or wrong only. Right? Normal C, even if you read slightly, the only difference is half a square division. Mistake. Okay,
Yes.
calculate the total elastic potential energy of the composite wire due to the weight of the block. Right? That's the formula that you use. 1 mark. Right? For G, calculate for H. Then add them all together. Add these two together. The original length of G is L. Original length of H is 2L. Calculate the ratio of cross-sectional area of G, cross-sectional area of H. So go to Young's modulus. Right? Take the constant all to one side. Force is constant. Young's modulus is constant. The same type of wire. So AX over L, one cross-sectional area, put a cross-sectional area on top also. Then for G, for H, then AG over AH, take AH down, XG down, LG up, and put in your value. Can anything not clear?
Yeah, it's clear.
On figure 5.1, mark a point X. Cross X the position of interference maximum. Label the cross Y. So that is your X, that's your Y. It can be here. There's a marking scheme. Oops. There's your Y. You have to imagine the minimum is center of there. It can be here. Okay, now
Yeah.
calculate the separation of A of the source A and B. The distance AB. Memorize the formula. Put in your value. Subject A, you want to find A, put in your value, calculate out. Take the principal region of electromagnetic spectrum to which the wave belongs. That's your wavelength. So what region of spectrum? Yep, can remember?
Say the principal region.
Yep.
So it should
Memory work.
be
Infrared 10 to the power minus 7 is about visible light. So that one is of the order of infrared, longer wavelength. Right?
yeah,
Remember
it should be
that?
infrared lah, I think.
Uh, right? The next one is that one can get for a sheet, right? If both of them, the the speed the speed of the car and the wave are traveling in the same direction, then you choose negative. If both of them are in opposite direction, then you choose positive. Calculate the speed of the train. Okay.
Mm.
Okay, let's carry on. Got 1 minute left. So after that, we see you on Thursday. Take the relationship. Right? They want you to use the formula. Intensity is at proportion amplitude square. So you just read from the graph, lor, then take the square root. Lor. Don't have to do all of them. Now take the first point and last point. Lor. And then take another point lor, just to check whether it's a straight line or curve. Lor. So it happens to be a straight line. Lor. Then, as your marking scheme,
Yeah.
only these 2 points are required. Lah. A third point to check whether it's a straight line or curve. Lor. Okay. Okay. Any comment? Anything
Yeah.
not clear?
No.
Anytime we cut off that, that's why I'm going a bit faster.